Hello everyone, my name is Avinash, working as a senior OCFP faculty at Orchids the International School. Welcome to our board exam SMART series. In this series, we will be covering the highly anticipated questions which were carefully curated by our expert faculties and making sure that it is aligned with our board exam pattern. This series is mainly concentrated to make sure that all the students will gain more than 90 plus marks. So what are we waiting for? Let's get started and make every session count. So, in our first session of our board exam SMART series, we are going to start with the chapter Light, Reflection and Refraction. So, before we start with the previous year questions, a small instruction to all the students. Pause the video for a few minutes before we go into the solution part. So, once a question has been displayed, I request all the students to pause the video and then go for the next question for the solution. Shall we start with the first question then? So it's a previous year question from 2024. It has been given for 4 marks. It reads as a table data has been given, and from this data you have to find out in which one of the above cases the mirror will form a diminished image of the object. Justify your answer. And the second question, the questions as follows: list 2 properties of the image in the case 2, and what is the nature of the image. So my sincere suggestion to all the students will be to redraw the figure like this, the table, something similar to this one, so that it becomes easy for you to answer the subsequent questions. So how do we start with? We will start with what the data which is given in shortcuts F and U. We will find out what is R. What is R? R is nothing but 2 times of the focal length. So 2 times of focal length, this will become 40 and this will become 30 and this will become 60. Now, what is how does it simplify our solution part? It makes us to identify the rest of the characteristics of the image and the object. So, what is the position of the object? See, you can see it is beyond C, C. So, you can write that as beyond C. Similarly, you have to fill up. This is at what position? It is exactly at C. And where is this position? It is the position is in front of the focal point. So it will be between pole and focus. Now let's understand the position of the image for the given position of the object with respect to the focal length. Now whenever you are beyond C, where is your position of the image formed? It is between focus and center of curvature. And this is a special case, as we all know. When the object is at C, even the image is also at C. And when the image is between the pole and focus, where do we get the image? It is behind the mirror. Behind the mirror. Now, what can you tell about the nature of the images? The nature of the image when it is between focal point and the center of curvature is, can you all tell? Real and inverted. Same is with the second case, which is at C. Same. Real and inverted we will be getting. But what about behind the mirror case? It will be virtual and erect. Now what can you tell about the sizes of the image? When it is real and inverted and when the object is beyond C, it will be diminished. It will be diminished. When it is at C, it will be exactly the same as object. Exact size of object. Now, when it is virtual and direct, what type of images do we get for we will go to the type of mirror, but we will keep it on hold. Okay, so have you identified for the first one? Where did you get the diminished size? Where is the solution? Here, diminished. So, in case 1, the size of the image will be minimum. And what about the case 2? The nature of the image is real and inverted, right? So, this is real and inverted and will be the same size as that of the object. Since where is it placed? It's exactly on center of curvature. Now, in case 3, the nature of the image is virtual and direct, while the size will be enlarged, because what is our mirror? It is our concave mirror. So, for a concave mirror, it will be forming an enlarged image. Okay, so they are even asking for the ray diagram. Pause the video for a few minutes and try the ray diagram for the last case. Right, so how did you get the image as? So if I go to the next problem, just give me a second. So students, when we look at the third question, which is drawing the ray diagram of the concave mirror in the third case. So let's draw the mirror with the shaded part on the opposite side to the reflecting side. Now where is the object placed? Between the pole and the focus. Right, so this is your object and this should be your C. Now in order to draw a ray diagram, we need minimum 2 rays. So let the first ray be passing through the pole. So if it is passing through the pole, we know it follows the laws of reflection. So if this is the incident ray, this should be your reflected ray. And let's project it to behind the mirror like this. We will pass it. And let's take the second example, second ray as parallel to the principal axis. This is the second incident ray. And what happens to the reflected ray? It should pass through the focus. So let's pass it through the focus. So this is your reflected ray, and likewise to the initial case, if we project it towards the back side, so the meeting point will be what? The image formation. So what is the image formation? It will be behind the mirror and it should be an enlarged case. So this finishes your the C part, but you know this is a 4-marker case study based question, so we do have an option of OR. So let's do the OR question. It is given that an object is placed, this is a completely different scenario from the given case study. So an object is placed at a distance of 18 centimeters from the pole of a concave mirror, and I have listed out what is given with the sign convention. So please be careful when you are studying, when you are solving problems, be careful with the sign conventions. So what is the position of the object at minus 18 centimeters? Remember, for convex mirrors and concave mirrors, your object should be always towards the left hand side. So it will be minus 18. And for a concave mirror, the focal point, the concave mirror, the focus is always towards the left side. So focus is also minus 12 centimeters. So we will try to find out what is R, which is minus 24 centimeters, 2 times of the focal length. Now since the object is placed between focus and center of curvature, the image will be formed behind C. Now what is the mirror formula? 1 by F is equals to 1 by V plus 1 by U. How do you remember this? People get confused with mirror formula and the lens formula. So my easy trick to remember the mirror formula is Madhya Pradesh and Nagaland. What do you mean by this? Mirror, M for mirror. So you will use the positive sign in between, and Nagaland for L means lens and N means negative. So this is a simple trick which I tell to my students also to remember what is exactly the mirror formula and the lens formula. So let's substitute. What else is waiting for you guys to solve? So let's substitute the values with the proper sign conventions. So what are they asking you to find out? They are asking you to find out V. So what is 1 by F? 1 by minus 12 is equals to 1 by V minus 1 by 18. So after transposing and everything, what is the final answer that you are getting? I am getting V is equals to minus 36 centimeters. What do you mean by this? How do you conclude the statement? This is a word problem. So conclusion with a proper statement is very, very important. So how do you conclude that? Is that the position of the image formed in case 3, okay, is 36 centimeters. 36 centimeters, is it in front or behind? That is important. So it should be written 36 centimeters in front of the mirror. So did you all get the same answer? Check your solution with proper steps and all. So students, let's move to the second question now. It has come as in 2023 for 3 markers. So the question reads as the image of an object formed by a lens. So the critical word here is, many students, they get confused with this one. The word is lens. They swap with lens and mirrors more or less often. So lens is of same size but inverted. So when do you get the same size and inverted? When you place the object on the center of curvature. So that is critical. So you should write, when you are answering in your answer sheets, you should write that the object is placed on C. So if you write this, you will get an idea at the starting itself, okay, my position is on C. So that it becomes easy to proceed for the next problems, next solution. So if the object distance, they have clearly given the object distance U to be 30 centimeters. But can you tell me what is the sign of this one? It is a convex lens. So objects are always placed to the left hand side. So it should be minus 30 centimeters. And where do you think the image will be formed? It is formed exactly on 2F. So even the image distance will also be 30 centimeters. But what will be the sign convention here? It will be positive because the image is formed towards the right side of the lens. So this will be positive. Now, do you think I need to use the length formula to find out what is the focal length? Because that is my first the question. There is one question, focal length of the lens. Do you think that I need to find out using the lens formula? No, not at all needed. Why? Why I should not use, or rather not need to use the lens formula? Because we already know the object is at 2f, right? So 2f, basically the focal length, gives us the radius of curvature, right? So this is 2 times of focal length is equals to 30. So what is your focal length? 30 by 2, which will be 15 centimeters. And what about the convex lens sign convention for the focal length? It will be always positive 15 centimeters. So you got the answer now, the distance, the focal length of the lens. Now what about the distance between the object and the image? So for that, let's draw the ray diagram. So it's a convex lens. I hope you all know how the convex lens looks. This is how a convex lens looks. Let's draw the principal axis and mark all the terminologies which we have learned, which is the focal point on either side, f1 and f2, 2f1 and 2f2. And what is the case about? It is the case where the object is placed on the center of curvature at 2f. So where is the image being formed? Again on 2f2, but on the other side. So if you draw the proper image, this is the figure. So what did they tell? This distance u is equals to 30, and what is the image distance? That is also 30. What is your first question here? The distance between the object and its image. You have to just add the distances. So add 30 and 30. So what will be the answer for this one? 60 centimeters. Got it? And your corresponding ray diagram has been drawn just to make sure that the proper rays are drawn. So let's complete it. So first, what is this point called as? It is called as the optical center O. So the first ray, we will pass it through O and make sure that it is coinciding with the tip of the image also. Where is the second image? Second ray should be going through the parallel axis, principal axis parallel to the principal axis, and let's divert it towards the focus so that your image construction is done. Clear with how it has to be done? So pause the video now. Let's move to the question number 3. So students, on the board is your question number 3. It's a case of a mirror. So a student wants to project the image of a candle flame on a screen. So what is the keyword here? On a screen. So that means you are using a screen. So if you are using a screen, what type of mirror is it? It is, yes, concave mirror. So you are using a concave mirror. So because in convex mirrors, is it needed a screen? No, because we always get a virtual and direct images. So we have identified what type of mirror. It is a concave mirror. So this is a question repeated even in 2014 also, and it has come for 3 marks. So this is a very, very important question. So please focus on this one. And after finding out the concave mirror, we have to find out the magnification and distance between the object and its image, and simultaneously we have to draw the ray diagram. So shall we proceed with the solution of the B part? So here it is. I have listed down the given, which is u with sign conventions. That is very, very important. So u is equals to minus 15 centimeters and v is also given as minus 60 centimeters. So what you need to identify, we have already identified it is a concave mirror. Now we have to find out magnification. So what is the formula for magnification in case of a mirror? Yes, we know m is equals to minus v upon u, or it is also given as height of the image by height of the object. So you have to remember these formulas for your understanding and for solving purpose. So which formula are we supposed to use? Because I have v and I have u, I'll be using this formula. So let's substitute the values that I have now. So it will be minus of minus 60. This is where many students commit mistakes. They will imagine that already I have a minus and they forget to write minus 60 and directly they will write it as 60. So please be careful. It is not just v, it is minus of v. So divided by minus 15. So what is the final answer that we are going to get? We are going to get minus 4. So is it an enlarged image or a diminished image? So if the values are greater than 1, obviously. So if m value is greater than 1, that means my image is enlarged. So remember this. And if your magnification is less than 1, we can tell that it is diminished. And what happens if it is equal to 1? M is equals to 1. What is the case? Same as the object. So that is the scenario of being on the center of curvature, same as object. So this you have to remember and practice thoroughly. So we got the magnification. Magnification is also done. Now they are asking what is the distance between the object and the image. Do you remember how we did the previous problem between the object and the image in the convex lens? Same case here. Because they are asking even the ray diagram, let's draw this for better understanding. So let's draw this. So a concave mirror it is. So I have drawn the concave mirror. So focus is here, and this is your center of curvature. And where is the object placed? Minus 15 centimeters. So where is the minus 15? So that will be between pole and focus. So let's place it here, the object, and let's draw the two rays. One is through the pole. So if I project it backwards somewhere like this, and the second one, let it be parallel, or let it pass through the center of curvature. I think that makes more sense. So if it is passing through the center of curvature, it should again pass, right? So we got m as minus 4. So we have identified if m is greater than 1, it is an enlarged image. But there is a negative symbol. What does it tell? It is a real and inverted image. So what cases do we get where we have an enlarged image and the image to be real and inverted? So where is the position of the object? The object will be between focus and center of curvature. So let's draw the ray diagram for the same. So if I draw the ray diagram, so let's mark all the given points F, C, and where did I tell my object is? In between focus and center of curvature. So let's draw the two rays which are required. One is parallel to the principal axis. So the reflected ray will pass through the focus. Okay, so it will go like this. And what about the second ray? Shall we take it to the focus? Yes, we can take it. So if I make it pass through the focus, the incident ray, so it will become parallel to the principal axis. So if I project it backwards, so this meeting point is your image. So this is your ray diagram for the third question. So students, this is your question number 4 from CBSE board exam 2023, and it has been given as a case study based question for 4 marks. Okay, so pause the video for a few minutes, read through the question and try to answer within 5 minutes. So let's move to the solution now. So it's a case study based question, and they have given the mirror we are using is a concave mirror. So they are in the first question, they are asking list 2 applications of concave mirror. So what are the 2 applications? Can you tell what are the 2 applications of a concave mirror? So it can be used as a telescope. In the telescopes we can use it, as well as in headlights also we can use it, as well as for solar cookers also we will be using it, right? So now coming to the next question, if the distance between the mirror and the principal focus is 15 centimeters, if the distance between the mirror and the principal focus, what did they give? What does this basically mean? Principal focus to mirror. Mirror means the pole. So they have given the focal length. Focal length, how much did they give? 15 centimeters. Okay. And what is the case? Find the radius of curvature of the mirror. What is the relationship between the radius and the focal length? R is equals to 2F. So it's very easy. 2 times of 15 will give me 30 centimeters. So these are very basic questions which will fetch you 2 marks easily if you can remember the applications of concave and the focal length. Now correspondingly they are asking to draw a ray diagram to show the type of image being formed. So let's draw the figure for this one when the object is between pole and focus. So let's draw it. Concave mirror. So focus, this is your pole, this is your center of curvature. Now, what is the case when the object is in between the pole and the focus? You will get an enlarged image. And do you get a real and inverted? No, we will get virtual and erect image. For this, again, the 2 rules, 2 rays we will be drawing. One passing through the pole, hitting the pole and just getting reflected back. So we will project it backwards. And the second one, you can take it passing through the center of curvature or through the focus. So I'm going to take it through the center of curvature for easy. And let's project it backwards. So this is your incident ray, this is your reflected ray. And when we project it backwards, where is the image being formed? It is being formed on the back side of the mirror or behind the mirror. And what type of image am I getting? I am getting an enlarged image. So we have done the C part, but there is an OR question also. So let's solve that OR question. So it is given that an object 10 centimeters in size is placed. So what do you mean by this 10 centimeters in size? That is the height of the object. So they have given h naught is placed at 100 centimeters in front of a concave mirror. So that means u they have given, which is minus 100 centimeters. Okay, so if the image is formed at the same point, what do you mean by image being formed at the same point? When do you get an image and object being at the same point? When the object is placed on the center of curvature. So what is the center of curvature? It is also equals to the object distance, which is 100 centimeters. What is the first question they are asking? They are asking you to find out the focal length of the mirror. So what is the, again, what is center of curvature distance from the pole? It is nothing but the radius of curvature, which is 2f. So basically they have given r is equals to the object distance, which is 100 centimeters. So what is f? F is equals to r by 2, which is 100 by 2. We will get 50 centimeters in front of the mirror. Okay, 50 centimeters in front of the mirror. Now let's calculate the magnification of the image formed with sin as. I told you already. So when the object and the image is being formed on C, what is the, in the previous problem I have told you, what will be the magnification? Magnification will be always equal to 1. But what about the sign conventions? So the sign convention is you are getting a real and inverted. So when you are getting a real and inverted, always the magnification will be minus. So what is the answer for the second one? M is equals to minus 1. So students, I have included few MCQ questions asked in the previous board examination, that is from 2020. So 2 questions I have listed here. The first one is, the laws of reflection holds true for. Pause the video and just think where we have applied the laws of reflection. Did we use it for all, or did we use it for any specific mirrors? So before going into this question, just try to recollect what are the laws of reflections. Laws of reflections, there are 2 types. The first one is incident ray, the normal and the reflected ray all will lie in the same plane. And the second one is angle of incidence and angle of reflection, both will be same. So these are the 2 laws of reflection, and when we studied, we have seen that it is applicable for all types of mirrors, no matter what, and even all types of reflecting surfaces also. So the correct answer for this one is all reflecting surfaces. Okay, so what about the next one? When an object is kept within the focus of a concave mirror, so where are we keeping? Within. What do you mean by within the focus? That means it is inside the focus. That means basically it is between pole and the focal point. Okay, so when we are placing the in between pole and focal point, we are getting an enlarged image that is behind the mirror. And what type of image? What is the nature of the image? It will be virtual and erect. So what is the answer for both of them? It is all reflecting surface for the first one and virtual and erect for the second one. So let's move to the question number 6. This has been asked as a 3-marker in 2020 board examination. The question reads as, an object is placed at a distance of 10 centimeters from optical center. So that means they have given your object distance u. So it is given as u is equals to, just a minute. So they have given u, which is, so u is equals to minus 10 centimeters they have given. And what else they have given? It is a convex lens. So underline these keywords in the paper also. It is a convex lens. And what is the focal length? Focal length they have given it as 15 centimeters. What is the sign convention for convex lens? For the focal length, it is on the right side. So focal length will always be positive 15 centimeters. So students, so what about your object? Where is it placed? Is it behind the focal point or in front of the focal point? It is placed because the length is less than the focal length. So it is placed in between the optical center and the focal point. So we have known that it is being placed in between the focal point. And let's draw the ray diagram. This suits us better. So this is your focal point, and this is your, how much is the focal point? This is critical, 15 centimeters. And where is, even on the opposite side also you have to mark it, which is F. This is also 15 centimeters. And where are you placing? At 10 centimeters from the optical center. This is your object, so this is 10 centimeters. Now, what is the scenario? What happens to the image? Where do you get the image? You are going to get on the right side or on the left hand side. So for that, first we have to find out where is the image distance. So let's find it out. So what is the lens formula? We will be using the lens formula for this one. So the lens formula, Nagaland, remember that. So negative sign will come. So 1 by F is equals to 1 by V minus 1 by U. So let's substitute with the values. 1 by 15 is equals to 1 by V minus of, again, I'm going to get another minus. So this will come out as 1 by 10. So if I substitute everything, transpose everything to the opposite side and then simplify, what I'm going to get is I'll be getting it as, did you get it? How much did you get? Minus 30 centimeters. I'm getting it negative. So that means, is it on the right side or the left side? So when you are getting a negative sign, that means my object is going to come on the left side. So okay, I got it on the left side. So where exactly am I supposed to place it? See, the focal point is 15. So where is your image? It is being formed exactly on the center of curvature. So this is your figure, and for this we have to draw the ray diagram also. So let's first draw the parallel ray first to the principal axis. So if it is parallel to the principal axis, where should it should go after refraction? It should go through the principal focus here. So let's mark the 2f also here. Then let's take the second one, which is if I project it backwards, it will go like this. So this is the meeting at the tip, and the second one I'm going to pass it through the optical center. I'm going to pass it through the optical center, and it will pass through the optical center like this. So this is where your object is formed. So critical here is, so you might think, sir, is it necessary to find out the minus 30 centimeters? It is needed, because where is it being formed? So sometimes we have to be critical where the image is being formed. So is it between the center of curvature and the focus, or behind the center of curvature, or exactly on the center of curvature? So it is critical to calculate even V as minus 30 centimeters for this question, because it is for 3 marks. Done? Yeah, so students, now let's move to the question number 7. This is a 5-marker question which has been asked in 2020 board examination. So there are 2 parts. Either you can attempt the first one or the second one. That's how it is given. So let's understand the first one. Draw a ray diagram in each of the following cases to show the formation of the image. So the first question deals with lenses, while the second question deals with the mirrors. So that has to be very clear for a student from a student's perspective. Okay, so the case is between optical center. Basically, they're asking you to draw the ray diagrams for this one. For this, what I have done is I have given you the solution also with all the ray diagram cases. What is the case for the first one? It is, where is it placed? Between optical center and principal focus of a convex lens. So it is which case out of these two? So you can see between the principal focus and the optical center. So it is case number 6 for the first question. For this, this is the ray diagram which has been given. Okay, what about the second case? The second case is anywhere in front of a concave lens. You are placing it anywhere in front of a concave lens. So which is the concave lens here? This is your concave lens. You are placing it anywhere. So let's place it in between infinity and optical center, where you are getting the image again in front of the mirror only, but it will be an enlarged image. But the thing is the next one, which is at 2f of a convex lens. Did you get the answer for this one? When you are placing at the center, what is 2f? Basically, it is nothing but the center of curvature. So if you are placing your object on the center of curvature, where will you get? Again on the center of curvature, but on the opposite side or on the other side of the convex lens. So this is okay. All these 3 problems are okay, fine. But what about the next one? State the signs. Students have the tendency to not read the entire question. So please be careful with the last. Read whether you have answered all the questions. It is given, state the signs and the value of magnification in the above mentioned cases 1 and 2. So for these 2 cases, if you have drawn the ray diagram perfectly, so which are the 2 cases here? It is question number, case number 6, and here the second case. So they are asking the state the sign and magnification. So what type of image am I getting here? Is it virtual and erect? Yes, it is virtual and erect. So what will be the sign? Is it positive or negative? Always remember, real and inverted is negative. Virtual and erect will be positive. So this will be positive, and will it be greater than 1? Am I getting an enlarged image or a diminished image? You can see here, it's more than the size of the object. So I'm getting an enlarged image. Is it the same case with this one also? No, right? You can see here, this is my object. And what type of image am I getting? I'm getting a diminished image. But am I getting a virtual and erect image? Yes, I'm getting a virtual and erect, because here the signs will be positive for both of them. But for a convex lens, it will be greater than 1. For a concave lens, it will be less than 1. So this is your first question. So I have solved the first question for you. If you have solved it, please do re-verify, and you have to practice the ray diagrams which I have shown thoroughly. So this is your first question. Let's move to the second question now. An object, this is a mirrors question, the mirrors case. An object 4 centimeters in size. What do you mean by 4 centimeters in size. Have they given the object distance or did they give the object height? They have given obviously the object height. Okay, so let's mark that. So object, so they have given the object height, which is HO. How much they have given? 4 centimeters they have given. Is placed 25 centimeters in front of a which type of mirror? Again, critical, concave mirror. So object distance U is equals to, what is the sign convention? Left side. So minus 25 centimeters. Okay, whatever the focal length of a concave mirror will be always negative. So F is equals to minus 15 centimeters. This is 15, just give me a sign. So this is 15 here. So minus 15 centimeters is the focal length. Okay, what they are asking now? At what distance from the mirror should a screen be placed to obtain a sharp image? What do you mean by that? They are asking what is the position of the image. They are asking you to find out the V value. Okay, so what is the mirror formula? Come on guys, I told you MP Madhya Pradesh mirror ka positive hoga. So 1 by F is equals to 1 by V plus 1 by U. So let's solve this. Everyone please pause the video. If you have not solved this, pause the video and try to find out the V distance. So what, according to the given data, it is minus 1 by 15 is equals to 1 by V minus, why it is minus? Because my object is minus. So 1 by 25. So if I transpose everything, so I'll be getting 1 by V is equals to minus 1 by 15 plus 1 by 25. So please do solve everything and you will get the what is the final answer. So this will be minus 5 here. Okay, and plus 3 here. So my final answer is minus 2 upon 75. That means my V value, I am getting it as minus 75 by 2. That is around minus 37.5 centimeters. What is my object distance? Image distance. It is minus 37.5. Is it beyond the center of curvature? Yes, you can see F is minus 15 centimeters and your object image distance is minus 35. So your radius of curvature is 30 centimeters. It is behind the center of curvature. So I am going to now find the size of the image. How are you going to find the size of the image? So you should conclude that the screen should be placed. Where should you keep the screen? At 37.5 centimeters in front of the mirror. That should be your conclusion statement. Okay. Now let's find out the size of the image. What is the formula for magnification? Magnification is equals to HI by H naught, which is also equals to minus V upon U. Okay. So we have already found out V. We have already have U. So we already have H naught. So let's substitute. So HI by H naught, always positive for the object because it is above the principal axis, is equals to minus of minus 37.5. Please be critical with the signs, divided by minus 25. Okay. So I request everyone to pause the video and simplify how much you are getting all these values as. So HI, if you simplify, you should be getting it as, so this will be minus 37.5 into 4 by 25. So students, after calculating, we will be getting the magnification value M as minus 6, the height of the image as minus 6 centimeters. Okay. So the height of the image will be minus 6 centimeters, or it is it real or inverted? It should be inverted. So the height of the image, you should conclude it is 6 centimeters below the principal axis. Below the principal axis. That should be your final answer. Okay, so this is regarding the size of the image. I am going to give the scenario for you to draw a ray diagram for this case. I am not going to solve it for you. You have to do it and you should be able to do it. That's my confidence. So students, let's move to the question number 8, which has been asked in 2019 as a 5 marks. So this is one of the most important question. So it's on concave lens. Till now we have studied about concave, convex and all. So we are going to study about the concave lens. So it is given an object is placed at a distance of 60 centimeters. That means they have given U. So U, how much did they give? And it is negative. So minus 60 centimeters. And what type of lens are we using? We are using a concave lens. So for a concave lens, what is the sign convention for the focal length? It is negative. F is equals to minus 30 centimeters because everything comes towards the mirror in front of the lens basically. Okay, so this has to be written properly as given. That is U is equals to minus 60 centimeters and F is equals to minus 30 centimeters. Now what they are asking the using lens formula. So what is the lens formula? 1 by F is equals to 1 by V minus 1 by U. So with proper sign conventions we will try to find out the distance of the image. So minus 1 by 30 is equals to 1 by V, and there is minus and another minus, will make it as plus 1 by 60. So after transposing and everything, what are we going to get? So minus 1 by 30 minus 1 by 60 is equals to 1 by V. So after further simplifications and all, you will get a V as minus 20 centimeters. That means even your image is also forming towards the left hand side of the lens. So what is the distance and where is it going to come? Is it between the focal point and the optical center or behind the focal point? So it is less than the length of 30 centimeters. You can see here the image is just 20, whereas focal length is 30 centimeters. So it is coming in between the optical center and the focal point. So let's draw the ray diagram first, then according to that we will list out the second answer also. So let's move to that. So what did we get? Let's list out all the given one more time so that it becomes easy for us to calculate. So U is equals to minus 60 centimeters, minus 60 centimeters, while I got my image distance as minus 20 centimeters and my focal length is minus 30 centimeters. Okay, so let's draw the diagram. Please remember it is a concave lens. So draw the figure properly. Concave lens I have drawn. Draw the principal axis. Mark the two focal points on either side, F, then the center of curvature 2F and 2F. Now where do you think you have placed your object? See, this is the object distance is double of the focal length. That means you are placing it on the center of curvature. Now in order to draw the figure we have to use two rays again. So one I will be using which is parallel to the principal axis, and once it is parallel to the principal axis it's a diverging lens, right? So it diverges like this, and when I project it backwards it will pass through the focus. So this is how it is going, and the second one I am going to take the ray as passing through the optical center. So if it is passing through the optical center, this is how it will look. It will pass through. It will not diverge or anything. It will just pass through. So where is your meeting point? This is your meeting point. So if I mark this as A and B, so your image is going to be as A dash and B dash. Now this is your image. This is your ray diagram. Now let's fill out the second question. List the four characteristics of the image. What is the nature of the image? What is the nature? Is it real or inverted or virtual and erect? You can see it is virtual and erect. So this nature is virtual and erect. What is the position of the image? Just now we have found out it is to be 20 centimeters in front of the mirror, that is between focus and the optical center. Sorry, in front of the lens, not mirror. And what about the size of the image? Is it diminished or enlarged? It is diminished. It is lesser in size. And coming to erect and invert, we have already listed it out. Okay, so ray diagram is done, this question is done, and we have used the to find out the distance of the image, which is basically the position of the image. I hope you all got the correct answer. Very good. Right. So till now we have dealt with the mirrors and lenses. There is one more important concept regarding the refractive index. So I have taken a question from 2017 2 markers. So it reads as, what is the relationship between the absolute refractive index of a medium and the speed of light in vacuum? So before going into absolute refractive index, what is exactly a refractive index? It is nothing but the ratio between the speed of light in the first medium to the speed of light in the second medium. If you want to find out the refractive index of the second medium. So what is the formula given? How is it given? It is given as, so we know the refractive index is denoted as n. So you need the refractive index of the second medium with respect to the first medium. So what is the formula for this one? It is nothing but the speed of light in which medium first? Speed of light in medium 1 divided by the speed of light in medium 2. So this is the case, or this is the definition, basic definition of the refractive index. Now what is What is exactly this absolute refractive index? The absolute refractive index is nothing but when one of the medium, basically the first medium, we are going to take it as vacuum. What are we going to take it as? If the first medium, if we are taking it as vacuum, then we call that particular refractive index of the medium which we are trying to find out, that is called as absolute refractive index. So let's find it out. N is equals to, what is the speed of light in vacuum? How do we denote it? In vacuum, speed of light in vacuum. You have to write this in your answer sheet also. Please don't neglect this. What is the symbol? C divided by speed of light in the medium, whichever that we are trying to find out. Okay, speed of light in medium. So that we will represent it with V. So what is the formula? Final answer, N is equals to C by V. Okay, this is the relationship. This answers your first question. N is equals to C by V. But there is another question. See here. And if the speed of light in vacuum is 3 into 10 to the power of 8, find the absolute refractive of some medium where the speed of light is 1.4 into 10 to the power of 8. So let's find it out. So they are asking, we know N is equals to C by V, which is 3 into 10 to the power of 8 divided by 1.4 into 10 to the power of 8. So N is equals to, basically you can cancel out 10 to the power of 8, 10 to the power of 8. So I'll get, if I remove the decimal points, that is 30 by 14, which will be 15 by 7. So the final answer is approximately 2.1, you will get it. So this is the refractive index for the given medium. So let's move to the final question of this session, which is, this is one of the most important question which has been repeated also. This has been asked in 2017 as a 5 marker. So pause the video. I'm going to move a little bit aside so that you can check the question. Pause the video and try to answer this within 5 to 10 minutes, because this is one of the important question. As a case study also, this can be asked. Okay, so let's move to the solution part now. So it is given, there is a data given from the observations that they have done. You have to find 3 cases. You have to answer 3 answers. What is the focal length of this convex lens? Okay, we got it is a convex lens. Done. You have to identify the serial number which is incorrect. This is most critical one. On what basis also you have to justify your answer, and then select an appropriate scale and draw a ray diagram for the second case. Okay, so remember these 3 questions. We are moving to the next slide so that I can answer it. Okay, so this is your question. So how did you identify the focal length? How did you find it out? How did you find out which is your center of curvature? That is the critical point. So the first thing that you have to do is identification of your center of curvature. Which is your center of curvature? We know in the center of curvature, the object distance and the image distance both will be same. So which case it is? It is case number 3. So that means your 2f is nothing but equal to 4. So what is your focal length? So this is focal length. So f is equals to 40 by 2, which is 20 centimeters, and since it is a convex lens, it will be positive. Okay, so we found out the focal length. How did we find out? Did you get the justification? You have to write the justification. In case 3, the object distance and the image distance are same. So when the object distance and the image distance are same, the object is placed on the center of curvature, and we know the center of curvature distance from the optical center is 2f. 2f is equals to 40, f is equals to 40 by 2. This should be your sequence of solutions. Then coming to the next question, which of these 6 observations is incorrect? Can you, I'm going to pause a little bit. Can you identify and tell me which is the correct, incorrect sequence here? Okay, fine. Your object is coming closer and closer to your, lens. Now when you are coming closer and closer, what should happen to your image distance? Yes, obviously it should increase. But there is one scenario where it is forming in front of the mirror, in front of the lens basically. So which is that case? That is between the optical center and your focus. What was the focal length we have found out? Our focal length was 20 centimeters. So correct? So our f is our f was 20 centimeters, and if you see this sixth case, it is minus 15 centimeters. So this is the scenario where it should be not minus 120 plus 120 centimeters. It should be in minus. So this is your incorrect statement. Okay, so this is your justification where since our focal length is 20 centimeters and the object distance is minus 15 centimeters, when the object is in between the focus and the optical center, where is your image supposed to be formed? It should be formed behind, not exactly behind, in front of the lens, that is in the same distance as in the same direction as the object has been placed. So it should be negative but not positive. Clear? So we have answered two questions, which is the first one about finding out the focal length and the second one identifying the incorrect observation. Now coming to the last one, what is the last one? To find out, to draw a ray diagram. To draw a ray diagram for which one? The second case. So for the second case, let's draw it, everyone. So where is the object distance? U is equals to minus 60 centimeters and V is equals to plus 30 centimeters, and we know our focal length is plus 20 centimeters. Okay, so what is the radius of curvature? That is 40 centimeters. So where is your object being placed? That is behind the center of curvature. So it's a convex lens, so let's draw it. I'm drawing it. Then passing it through the optical center, mark the focal points and the center of curvature 2F, F, 2F I have marked. Now where is your object? Is it behind the 2F or in front of the 2F? So it will be somewhere behind the 2F. So two rays, let's draw it. One, I am going to take it as parallel to the principal axis. So if it is parallel to the principal axis, what should happen to the refracted ray? It should pass through the focus. So let's pass it through the focus. So it is passing through the focus like this. Now the second one, I'm going to take it as passing through the optical center. So if it is passing through the optical center, will it, how does the refraction go? Will it divert? No, it will directly pass through the optical center. So when I'm passing it, so where is the meeting point coming? Here. So my observations, is it correct or wrong? You can identify with the image distance. What is the image distance? 30 centimeters. Your 30 centimeters is in between these two, right? 20 and 40. So my diagram has come correct. So you can cross verify your observations or your diagram properly with the given values also. Okay, now let's list out all the characteristics also. What type of image am I getting? Is it real and inverted? Is it real or inverted? It is an inverted image. Okay. And are you getting it on a screen? Yes, I am supposed to get it on a screen. And what about the size of the image? Will it be enlarged or will it be diminished? It will be a little bit diminished size. So students, till now I have shown you the 10 previous most anticipated questions till now, but don't confine yourself to these 10 questions. These are just for references which you can practice, and you can use many online resources for those previous year questions also. And before I conclude, I have listed some important relationships which we have gone through this entire session. So listing out the mirrors and what about the relationships that we have regarding the characteristics of the image, similar to the lens also. And even I have listed down the mirror formula and the magnification formula, and similarly the lens formula and the magnification formula. So please do practice these questions thoroughly, and I hope it's though the main objective of these sessions are to score above 90 plus marks. My main suggestion for you is your target should always be 100 out of 100. So all the best for your board examinations, and hope you all will come out with fruitful colors. Thank you.